If every human worker in a factory disappeared tomorrow, what would take their place? Imagine walking into an industrial hall where machines lift entire cars, steel beams, and multi-ton engines as if they weighed nothing, with perfect precision, all without a single human hand involved. Here's the thing, these machines don't look like people at all. They don't walk, talk, or imitate human movement, and yet they're already stronger than any human, or even any group of humans, could ever be. So today, I'm going to show you the 8 strongest robots from China. Many of them already built, deployed, and working at massive industrial scale. And make sure you stay until the end, because the robot at number 1 is so powerful, it handles loads that normally require cranes, crews, and entire support teams. Number 8, SZGH Vanguard W8. We start our list with a robot that may not look intimidating at first glance, but don't let that fool you. The SZGH Vanguard W8 is a heavy-duty industrial robot built in China, designed for one thing: controlled power. It can lift up to 250 kilograms, which might not sound extreme compared to what's coming later, but in the world of precision robotics, this level of strength is anything but ordinary. To put that into perspective, that's the weight of a full industrial engine block, lifted, rotated, and positioned with millimeter-level accuracy. What makes the Vanguard W8 stand out isn't just how much it can lift, it's how precisely it does it. With repeatability as tight as plus or minus 0.04 millimeters, this robot handles heavy welding and material handling tasks where even the slightest error could ruin an entire assembly. Built and deployed in China's smart factories, the W8 operates non-stop in harsh industrial environments, handling thick steel components, massive weld joints, and high-stress workloads that would overwhelm lighter robots. And if this is only number 8, imagine what kind of power is waiting higher up the list. Number 7, Estun ER30 Heavy Duty. At number 7, we have one of the most important workhorses inside China's industrial machine. The Estun ER30 Heavy Duty may not grab headlines with record-breaking numbers, but it represents something far more significant: scale. This robot is designed to lift up to 300 kilograms, making it a critical player in automotive manufacturing, metalworking, and large component assembly across China. See, 300 kilograms is the weight of a fully assembled electric vehicle battery pack or a massive engine module, and the ER30 handles these loads repeatedly, shift after shift, with unwavering consistency. What truly sets the ER30 apart is its precision under load. With repeatability as tight as plus or minus 0.05 millimeters, it lifts heavy components and positions them exactly where they need to be, even in high-speed production lines where errors are costly. This robot is widely deployed across China's massive automotive sector, the largest in the world. Instead of relying on imported systems, factories use the ER30 as a domestically engineered solution that combines strength, reliability, and cost efficiency. China's strength in robotics isn't just about extreme machines at the top, it's about thousands of powerful robots already doing the work every day. Number 6, ABB IRB 8700. Now we step into a completely different class of strength, where heavy lifting meets industrial speed. The ABB IRB 8700 is capable of handling up to 800 kilograms, and in certain configurations, even 1,000 kilograms when operating wrist down. That puts it firmly in the ultra-heavy duty category, where robots start replacing not just human labor, but entire material handling systems. What makes the IRB 8700 truly impressive isn't just how much it can lift, it's how fast it does it. While most robots this strong move slowly to stay stable, the IRB 8700 breaks that rule. It operates up to 25% faster than other robots in its payload class, allowing factories to move massive engine blocks, transmissions, and structural components without slowing production. This speed comes from ABB's unique design philosophy. Instead of using complex multi-motor systems or gas springs, the IRB 8700 relies on a single motor per axis, paired with an optimized counterbalance system. Fewer components mean less inertia, higher reliability, and lower maintenance, all while handling extreme loads with precision. Even under maximum payload, the IRB 8700 maintains millimeter-level accuracy, ensuring that heavy components are placed exactly where they're needed. That combination of strength, speed, and control is why this robot is widely used in automotive and heavy manufacturing plants around the world. At this point in the list, we're no longer talking about strong robots. We're talking about machines that define how modern factories move massive objects at scale, and the robots ahead only push that idea even further. Number 5, Youibot L1000. The Youibot L1000 is an autonomous mobile lifting robot from China, capable of carrying up to 1,000 kilograms while navigating factories and warehouses without a human operator. That's a full metric ton moving freely across the floor, guided by sensors, cameras, and AI-based navigation. To put that into perspective, this is the kind of weight traditionally handled by forklifts, pallet trucks, and human drivers. The Youibot L1000 replaces all of that with a single machine that never gets tired, never needs brakes, and never makes judgment errors. What makes this robot especially powerful is its combination of strength and autonomy. Using laser-based SLAM navigation and visual positioning, it can detect pallets, dock automatically, avoid obstacles, and coordinate with other robots in real time. Multiple Youibot units can operate together, moving massive loads across an entire facility with almost no human oversight. In modern Chinese factories, robots like the L1000 are already transforming logistics. Heavy pallets, battery packs, and industrial components move continuously from one workstation to another, without forklifts, without drivers, and without stopping production. Up until now, strength meant lifting power. With the Uabot L1000, strength also means mobility. And as we move closer to the top, that raw power is about to grow even more extreme. Number 4. KUKA Titan KR1000. Next, we have reached a robot that earned its reputation through sheer mechanical force. The KUKA Titan, also known as the KR1000, is a legendary ultra-heavy-duty industrial robot capable of lifting up to 1,000 kilograms, and in specialized palletizing configurations, even more. When it was first introduced, it completely changed what engineers believed a robot arm could handle. What makes the Titan unique is its 9-motor architecture. Instead of relying on a single motor per axis, KUKA distributed power across 9 high-performance servo motors, generating a level of torque comparable to a mid-size car engine. This allows the Titan to lift massive engine blocks, aircraft components, steel beams, and stone slabs that once required cranes. Despite its size and weight, nearly 5 tons of metal and motors, the Titan is anything but clumsy. It can position enormous loads with millimeter-level accuracy, aligning heavy components precisely on fast-moving production lines. The KR1000 became a cornerstone of heavy manufacturing in automotive plants, foundries, and aerospace facilities around the world. It proved that robots could replace cranes not just for lifting, but for precise placement under extreme load. Number 3. MIR1350. The MIR1350 is an autonomous mobile robot capable of transporting up to 1,350 kilograms completely on its own. That's more than a full metric ton moving through a factory floor without rails, without operators, and without fixed infrastructure. To understand how impressive that is, imagine a loaded industrial pallet, stacked with metal components, battery modules, or engine parts, gliding across a warehouse by itself, navigating corners, avoiding workers, and adjusting its route in real time. That's exactly what the MIR1350 does, every single day. What truly sets this robot apart is its freedom of movement under extreme load. Using laser-based SLAM navigation, sensors, and onboard computing, the MIR1350 continuously maps its surroundings, detects obstacles, and reroutes automatically when paths are blocked. It doesn't follow predefined tracks. It thinks its way through the environment while carrying more weight than a small car. In modern factories, this capability is transformative. Instead of relying on forklifts, conveyor belts, and human drivers, companies deploy fleets of MIR1350 units that move massive loads non-stop. Materials flow continuously between storage areas, assembly lines, and shipping zones, without pauses, without fatigue, and without safety risks associated with human-operated vehicles. This robot doesn't just lift weight, it redistributes strength across an entire facility. Number 2. Kawasaki MG15HL. Next, we meet a robot built for one purpose: absolute industrial dominance. The Kawasaki MG15HL is capable of lifting an astonishing 1,500 kilograms. That's the weight of a full automobile body, raised, rotated, and positioned with robotic precision. Not by a crane, not by multiple machines, but by a single articulated arm. What makes the MG15HL truly terrifying is its wrist power. This robot delivers an incredible 15,000 Newton-meters of torque, the highest wrist torque ever achieved in an industrial robot. That means it doesn't just lift heavy objects, it can twist, rotate, and control unbalanced loads that would overwhelm most machines. In real factories, loads are rarely perfectly centered. Car bodies, massive castings, and steel frames shift, tilt, and resist movement. The MG15HL was designed specifically for this reality. Its wrist can overpower uneven weight distributions without losing control, maintaining stability where other robots would fail. Kawasaki achieved this through a patented hybrid link mechanism, eliminating the need for bulky counterweights that limit movement in other heavy robots. The result is a machine that combines brute force with surprisingly compact design, allowing it to operate in spaces where cranes or traditional lifting systems simply can't fit. Despite its strength, the MG15HL maintains plus or minus 0.1 mm repeatability, meaning it places multi-ton components with the precision of a surgical instrument. This level of control is essential in automotive body assembly, large-scale welding, and high-force operations where even small misalignments can cause catastrophic errors. Now, machine at number 1 goes even further, lifting more weight than anyone thought possible for a robot arm. Number 1. FANUC M-2000/2300. At number 1 stands the undisputed heavyweight champion of industrial robotics. The FANUC M-2000IA/2300 is officially recognized as the strongest robot in the world, holding the Guinness World Record with a staggering 2,300 kilogram lifting capacity. No other industrial robot arm comes close. To understand what that means, picture an entire automobile, chassis, body, and all, being lifted sideways, rotated in midair, and positioned with absolute precision. That's not a demonstration. That's normal operation for this machine. What makes the M-2000IA/2300 extraordinary is its control under extreme load. Despite handling more than 2 metric tons, it maintains placement accuracy within plus or minus 0.08 millimeters. In other words, it can move objects heavier than a pickup truck and still align them more precisely than the thickness of a credit card. The robot's massive structure, reinforced joints, and high moment wrist allow it to manipulate unbalanced and shifting loads, the kind found in real factories, not lab conditions. That's why it's used in automotive plants and heavy foundries where complete car bodies, giant castings, and structural assemblies must be moved continuously, day and night. At nearly 12 tons of total system weight, the M-2000IA/2300 replaces cranes, support rigs, and entire material handling workflows with one precise, programmable system. It doesn't just lift heavy objects, it redefines the upper limit of what a robot arm can physically do. When you reach number 1, there's no debate left. This isn't just the strongest robot on the list, it's the strongest robot ever built. Strength is no longer measured by muscle, endurance, or human limits. Across factories, warehouses, and industrial hubs, it's now defined by payload capacity, precision, and non-stop operation. The robots you've just seen represent the peak of that shift. From heavy-duty workhorses deployed at massive scale to ultra-powerful machines capable of lifting entire vehicles on their own, these systems are quietly reshaping how the modern world is built. They don't get tired, they don't slow down, and they don't need teams of operators to do what once required cranes, crews, and complex logistics. So which of these 8 strongest robots impressed you the most? Let me know in the comments. And if you want more deep dives into the technologies quietly reshaping industry, automation, and global power, don't forget to subscribe.